All right, we're back. We're still on page one of, I guess, notes 11. Yeah, notes 11 of Calc C, and we did four kind of review problems, right? All of these are things that you could have run into in Calc AB. We had direct U substitution. We had two options, and I did it wrong, so that was awesome. But I went back and fixed it eventually. Two options here. I think this is the standard approach. This is like the insightful approach, which is awesome. And then here we have three options because we can make either of the given things u, or we could notice that the integrand itself is basically sine of 2x, sine of 2a, but it's 1/2 of sine of 2a, and then we go from there. And then I almost left out the negative sign there, but I went back and I caught that mistake. So not on my not on my best game there, not on my A game. Didn't bring my A game, I guess. I don't know. All right. So we kind of talked about it and we saw a little bit of it. There primarily are two types of things that are going to help you do these integrals. And what I would recommend is that you just remember the things that you can use to help you, because it's kind of a nightmare to try to memorize all the scenarios. So what we're going to do is we're going to remember the three Pythagorean identities. So these are the fundamental identities, math analysis, if you were in my class like years ago, 2 years ago probably, or I don't know. I mean, if you're doing this in college, it could have been like forever ago. Or maybe you graduated and you went back, or maybe you never had me, who knows? All right, the most famous one is sine squared of x plus cosine squared of x equals 1. I mean, that's the basis of everything. That's the most famous. Now that means that you could always replace sine squared with 1 minus cosine squared. You can always replace cosine squared with 1 minus sine squared. So you can always take an even power of either sine or cosine and turn it into the other function. That's the key. Now, the next one is 1 plus tan squared plus 1, I guess. Tan squared plus 1 equals secant squared. So I have it memorized, but what I just did was I looked at this and I divided everything by cosine squared, right? This over cosine squared is tan squared, this over cosine squared is 1, this over cosine squared is secant squared. What does this mean? It means you can always replace secant squared with 1 plus tan squared. You can also always replace tan squared with secant squared minus 1. So just remember the identities and then, basic algebra, and you'll be able to work out some substitutions. And then this one, I think, is far and away the least used, but I mean, it's just as valid. 1 plus cotan squared is equal to cosecant squared. So same thing, you could always turn an even power. Basically, you can always turn an even power of any of them into a different function by using the Pythagorean identities. So these are going to come in handy. We're going to use those a lot. Now, the other thing that we need is the cosine of 2x. So cosine of 2x has three different ways you can write it. The one that I've currently given you, because I don't know if everybody just remembers cosine of 2x, is not the one you're going to use. So what you do is you actually use the Pythagorean identities. And so, you'll do cosine squared of x minus the quantity 1 minus cosine squared, because sine squared is the same as that. So this, I mean, you should also just remember these, but you may not. Cosine squared minus 1. We do the same thing and end up with 1 minus 2 sine squared. Like so. All right. So now how are these helpful? In and of themselves, maybe they're not that helpful. But if you solve them, we're going to solve this for cosine squared. We're going to solve this for sine squared. So I'm pretty confident you can do that. So I'm just going to write them down. So this, well, actually, the way you write them, you can do whatever you want. I think you should write 1 minus cosine of 2x over 2. And then here you would write 1 plus cosine of 2x over 2. The reason I write them that way is that I find it easier to remember. It's like, I feel like cosine should go with cosine, so the plus makes sense to me. I feel like cosine shouldn't really go with sine, so the minus makes sense. It's like a warning, like, why are you mixing them? But you can mix them. That's how I remember them, whatever. So let's see if we can actually use them to evaluate these. So now it becomes a question of like, I see an even power of sine. Does it make sense to turn it into an even power of cosine? in which case I have essentially the same integral, like whatever problem I have with this integral, I have with that integral, because there's nothing to help. Or should I use this? This is called a power reducing formula because it reduces the power, right? I go from squared to first degree, and I can deal with that. So I'm gonna reduce the power. So here, well, I'm gonna use a marker to do it. This is gonna become 1 minus the cosine. So it's a cosine of, I just accidentally clicked on a software update. The important thing here is that this is x and it's 2 times x, right? So I need to do 2 times this thing. So that's going to become 6x. 2 times 3x is 6x over 2 dx. And then we just integrate this. So you can break it up, or you could do this, 1 minus. When you're doing a lot of these, you end up just factoring that 1/2 out like right away because it's always there. You get x. And then here, I'm going to get minus 1/6 sine of 6x plus c. So you could redistribute or you could leave it out. It doesn't make a difference. Checking these on your calculator is kind of a nightmare because there's like no telling what the calculator is going to like choose to do. So you often have to just take the derivative of your answer and see if it's equivalent. So here I'm going to do the same thing, but I'm going to pull out the 1/2. And I get 1 plus the cosine of 2 times 4x, so 8x. So I wouldn't want to change this into sine. I wouldn't want to change it into sine squared because like same problem, right? Like if I didn't know how to do the cosine squared thing, then I don't know how to do the sine squared thing. So that's usually your hint, like power reduce. So 1/2 x minus 1/8 sine of 8x. For whatever reason, I feel like this particular like form of it comes up more often. I feel like you integrate cosine squared more than you integrate sine squared. I don't like, ooh, I just turned my iPad off. Hold on. I don't know what that does. Okay, that does nothing. That's weird. I don't know why I think that, but like also, well, no. Like I'm dumb. I'm not even like thinking this through. It's not that you integrate sine squared or cosine squared anymore. It's that you always turn them into the integral of cosine. And because you're always turning them into the integral of cosine, you always end up with the sine thing. Also, I'm seeing that I made a mistake here. This should be plus. Okay. So you always end up with the sine at the end. That's what I was thinking, because you like frequently end up plugging in pi and 0. And since you're plugging in pi and 0, the like sine parts just kind of like go away because that sine of 0 is 0, and the sine of pi is 0. Anyway, I'm like I'm a little out of it or something. I don't know, but you know, I'm gonna check these on the calculator just in case, because this is not going smoothly. I'm not gonna redo the video because I just like don't have time in my life for that. But so if I do the integral of the sine of 3x and then square it, comma x. So I get this. So what has the calculator done? The calculator has done something weird. Well, it's not really that weird. Let me try this. T collect the answer. So what it did was it used the double angle formula for sine. Like our answer was sine of 6x, or had a sine of 6x. It turned the sine of 6x into 2 sine of 3x cosine of 3x. Just obnoxious. But anyway, that is the answer. That is the answer that we got in very strange form. And then if we integrate the cosine of 4x squared, x, it does it again. Oh, why are you doing that? So for this one, I'll try to check it by just typing the answer that I got. 1/8 sine of 8x. So this is where you run into it. And then the plus c can kill you too. Okay, so why? T expand. So those are in the algebra menu. Oh, no. Let's do T collect on this. T collect. I'll go find them in a second. T collect. There you go. And you can see that it's equivalent. Nothing you can do about that. If you go to the menu 3 and then press up, you get trig, and you have trig expand, trig collect. So it's not always clear to me what that's going to do. I mean, in my opinion, trig collect should always make something smaller, and expand should always try to make it bigger. It seems inconsistent, so I end up doing like both to both. Like I end up using both of them on almost every problem where I end up using them. because it doesn't take long. So, you know, try one, see if it does what you want. If it doesn't do what you want, go back, try the other one. All right, that is the end of this page. Took me a long time, but finally got here. All right, so I will see you in the next video when I think we're just going to be doing problems. Maybe, yeah, I think like problems for days, but who knows? So I will see you there.